Welcome to homogeneous linear first order equations. So the general idea, if we have homogeneous linear first order equation of the form or y prime plus p of x, y equals 0. We can go ahead and separate the variables. So we have y prime is equal to negative p of x times y, which therefore gives us the y prime over y is equal to negative p of x. If we then integrate both sides, then we have the integral of y prime over y is equal to negative the integral of p of x dx. That left-hand side is just the natural log of the absolute value of y. Right-hand side is negative the integral of p of x dx. And I'm going to just quickly move the next problem. Oops. To give myself that tiny bit more space. There we go. So we have the natural log absolute value of y is equal to negative integral of p of x dx, or y is equal to e to the negative integral of p of x dx. So this is a very, very simple separable equation. Every single homogeneous linear first order equation fits this form and therefore has solution in this format. So for example, if we wish to find the general solution to y prime plus 4 over x squared y equals 0, we have then that y prime over y is equal to negative 4 over x squared. That means that the integral of y prime over y dx is equal to the integral or negative integral of 4 over x squared dx. That left-hand side is just the natural log of the absolute value of y. Right-hand side, if we integrate negative 4 over x squared, that is a negative 4x to the negative 2 goes up to negative 4x to the negative 1. We divide by a negative. We wind up just with 4 over x plus c1. If we then do e to the on both sides, so if we do, if we take e to the on both sides, we get that the absolute value of y is equal to e to the 4 over x plus c1. And then if we again set c equal to plus or minus e to the c1, we wind up getting that y is equal to c times e to the 4 over x. So you could have kind of jumped straight to close to that last line if you wanted to just use the little formula we developed here. or you can run through the process. So again, first order linear homogeneous differential equations have a very specific equation for quickly getting the solution, but you can just re-walk through the process quickly as well. In the next video, we will go ahead and look at non-homogeneous first order linear differential equations.